Hello everyone, I'm honored to be here to join this conference. My topic is Available Light Indoor Location System based on Lambert Optimization Model, RSS Fingerprint Database Algorithm. Here are the authors and email of this paper. As follows, my presentation will cover 4 aspects: research background and significance, location algorithm introduction, system software implementation, results and conclusion. First, let's focus on the research background of this topic. We can see from this chart, in recent years, visible light communication technology has been increasingly mature, and the scale of investment in the industry has also gradually increased. Visible light communication technology has effectively made up the deficiencies of existing wireless communication technologies, such as low positioning accuracy, high power consumption, and slow speed. Compared with other wireless communication technologies, visible light communication technology has its own preeminent advantages, such as rich spectrum resources, unrestricted use of sensitive areas, high confidentiality, and low cost. And we can speculate that indoor positioning is expected to become a blue ocean in the field of positioning devices, and it will open a new journey of seamless connection between indoor and outdoor positioning, which contains huge business opportunities. And the significance of this research are following: improve accuracy, reduce latency, obtain low consumption, and obtain the Internet of Things. Well, let's move to the theoretical model of this research. In order to further improve the positioning accuracy of indoor positioning based on visible light communication, we propose an RSS fingerprint database location algorithm based on Lambert optimization model. The main work we have done can be summarized as 2 parts. First, let's focus on the Lambert optimization model proposed by this article. In general, we regard the lighting model of a single LED as the Lambert radiation model, which has the parameter Sm, just shown in the formula. However, most LEDs do not contain only one lamp bit, but may contain multiple lamp bits. In this case, we proposed a Lambert radiation parameter optimization model, and the Lambert optimization model diagram is shown on the left of this screen. By this way, we can obtain a discrete sequence M about Lambert parameters by a certain step distance, and each element of Mg in the sequence can be used as the Lambert radiation coefficient to conduct ranging for the reference point AI with a known distance of di, and the measured value can be obtained as dij. And the Lambert optimization parameter solution is shown on the right of this screen. PO and PA are the formula. When either of di and dij is the minimum, and the corresponding mg is the reliable estimate value of Lambert parameter in this direction, then we can obtain the linear distance between point AI and point O in the projection plane. Furtherly, let's move on the RSS fingerprint database location algorithm. We use this optimization model to mark out a small illumination region as A1, A2, A3, and A4. In this illumination region, using Lambert optimization model, we can find the optimal Lambert radiation coefficient M and R. Then, using the principle of three-side measurement, by solving a system of nonlinear equations, just as shown on the screen, and we can obtain coordinates location x, y of object point. Next, let's move on the system software implementation. The structure of the system software implementation is shown in this figure. The system consists of photoelectric detector, which receives the signal from free space. Then it will convert to digital signal, and after digital filtering, the system will build up a fingerprint database and store in memory unit. Then, we are running the optimization location algorithm program. The location of the object is obtained. And by using Wi-Fi devices with microprocessor to develop a gateway agent, the Internet of Things technology is used to realize the connection between devices and mobile phones, and the positioning information is transmitted to mobile phone clients in real time. Well, let's move on the implementation process of optimization location algorithm program. One part of the key codes is shown in this figure. By those codes, we can find a Lambert optimization parameter. The system will calculate corresponding Lambert parameters of 4 reference points respectively, and deposit them into the array following the growing up order. Then, get the corresponding Lambert parameters in the direction of the extreme value by doing 400 times step by step. Coexist in the array. Then calculate the light power of this point using each element of array, and match the object point information once again to find the best Lambert radiation parameters. and then calculate the distance between the object point and the three sources respectively as R1, R2, and R3. While purging in Formula 6, finally, using RSS to find out the coordinate of the object point. Then, I will show you the results and analysis. Here, the positioning error is defined as the absolute gap between the actual location of the object point S0, Y0, and the detected location by this system X, Y, and it also uses the standard gap sigma and the average error mu as follows. And the results are shown in this figure. We can find that the test point with positioning error are under 30 mm occupy nearly 63%, and the test point with positioning error are under 40 mm occupy nearly 95%. In addition, we can find that the positioning error distribution between 20 to 40 mm basically, and the center value of Gaussian fitting curve is nearly 26 mm. Finally, I would like to make a conclusion with my presentation. The system can only obtain basic error in 70.7 mm through using traditional fingerprint algorithm, which take the nearest full fingerprint date at the object point coordinate, where this system can realize the average positioning error less than 13 mm through using RSS fingerprint database location algorithm based on Lambert optimization model proposed by this paper. In addition, this system has ideal speed, high presentation, small time consuming, and low cost of power consumption, and without any complicated sensors, synchronization devices, which has a good development and application value. In future, it can achieve free or portable positioning while improving the hardware design of the receiving device and adopting a mobile power supply, so that it can be minimized for easy wearing. And for the last mile of navigation, we can consider using visible light indoor positioning technology to achieve seamless connection between indoor and outdoor positioning. That's all my presentation. Thanks for listening.
Hello, I'm Yang Yuhan from Next China University of Water Resources and Hydropower. Now I would like to introduce my paper, Target Detection Algorithm based on faster CNN from 4 aspects. Research background and significance, research states and analysis, research contents, conclusion. Research background and significance. The purpose of target recognition is to confirm the detected target objects. To classify them is one of the most important research topics in computer vision, image processing, and machine learning. At present, it would be widely studied in the field of transposition, machine learning, intelligent value surveillance, industry dictation, national defense. At present, deep learning is being widely applied in the field of image processing, computed with traditional image data analysis technology. The conclusion obtained by deep learning technology are more accurate and comprehensive and widely applied in many fields. Research states and analysis. Traditional image detection. Traditional image algorithm simply added a special candidate reading in front of CNN to generate the network, which is time-consuming and leads to a waste of resources and time. Traditional image recognition includes image processing, feature extraction, classifier design, and so on. Various operators are used to process the extracted target characters features. Traditional image processing method use image masking technology, which is mainly divided into 2 categories. One is statistical matching algorithm. The main methods include mean, absolute differences measure, mean skew, error measure, and matching algorithm based on degree across correlation measure. The second type is feature-based matching algorithm, that is, exciting features such as boundary, text feature, entropy, and energy from the image, and using these features for matching to achieve the purpose of fast matching, so as to transform image matching into matching with a small number of features, improve the operation speed, and reduce geometric distortion and grid level change. Image detection based on deep learning. In the process of improving the image processing algorithm, some excellent data sets gradually appeared, such as ImageNet, Training Set, VOC dataset, FDDB dataset Act. These datasets have a wide variety of types and a huge amount of data, which solves the problem of overfitting in the training process to a great extent. At the same time, with the improvement of computer, processor, CPU, and graphics card GPU performance coupled with the continuous emergence of new algorithms and new frameworks, target detection have been prompted to develop rapidly. Today, there are a lot of image recognition based on deep learning network. It's the most basic convolutional neural network, CNN, convolutional neural network. With the improvement of science and technology, more and more network model is applied to image detection, such as RCN, fast RCN, yellow SCCD, and fast RCN model, such as to improve the accuracy of the algorithm to identify at the same time. With the depending on modern level, the model can be better learning the characteristics of the target object, get better detection results. Number 3. Research contents. Fast RCN model. The fast RCN target detection network is mainly divided into 2 steps. The first step is to locate the target. An image is input into the feature extraction network, and the feature map of the image extracted through a series of convolution and polling operations. The task of tag detection is not only to detect targets, but also to find candidate targets and locate them on the feature map through RPNet. The second step is to classify the specific securities of the target. Distance box regression is used to modify the position of the candidate target to determine the final candidate target range. Use the softmax classifier to identify the categories of candidate targets in this paper. The classification network is used to determine whether the candidate range belongs to the target of interest, so as to realize the detection of the target of interest. The schedule of the fast RCN is shown on Figure 1. Part 2. Residual network model. In this paper, the ResNet 101 model based on convolutional neural network is improved to achieve feature extraction compared with AlexNet VIC-16 and other feature extraction networks. Its features are as follows. ResNet USA as the fast identity mapping network, the fast connection approach, which generates neither additional parameters nor computational complexity. As shown in Figure 2, a quick connection simple performs an identity map and adds its output to the output of the overlay. Through SGD backpropagation, the whole network can be trained end-to-end. Part 3. Improved reading proposal network. This paper attempts to improve the residential statute on the barriers of the traditional ResNet 101 and accompanied with the characteristics of the picture. By increasing the width of network, this paper extracts the deep features of the targets so that the network can learn the key identifiable features. Therefore, we propose an improved deep residual network structure to improve the target recognition accuracy. The residual elements used in this paper adopts 2 parallel 3-3 convolutional layers. The function of one RAD1 convolutional layer is to change the dimension. 2 parallel 3-3 convolutional layers inherit the performance of vague network. Part 4. Experimental results and analysis. In this paper, the training set and test set of the dataset are used, and the experiment TensorFlow framework is used to implement the convolutional natural network model. In fast RCN, random inactivation, maximum iteration value, batch capacity, and other parameters have a great impact on the average precision value (MAP). These parameters need to be compressed for better output. In the experiment, the maximum number of inversion was 7,000. The batch processing scale of FPGA network was 256, and the random inactivation value was selected as 0.6. The first experiment is to test the average detection accuracy and spread of the target detection network in the area number adjustment layer. After many experiments, the acceleration speed is increased by 150% on average, with little loss of precision and a lot of cost saved. Part 5. Experimental Results and Analysis. Experiment 2 mainly compared the detection accuracy under different feature extraction models. It can be seen from Table 2 that the improved model has the highest accuracy rate, which is 3 points higher than the original model. In other words, for AlexNet and the original feature network, the improved feature network can better extract features of images with higher accuracy. At the same time, the improved AlexNet 101 network mode has the highest MAP value. That is, the target network model has better performance, thus improving the model identification accuracy. Therefore, the improved model detection effect is better. Number 4. Conclusion. Aiming at the problem of target recognition, accuracy, and influence detection of target positioning intelligibility. A method based on fast RCN framework is proposed to improve its feature network ReseNet 1.101, and the algorithm network is proved. The following conclusion can be drawn. The design of ReseNet 101 feature extraction network based on convolutional neural network is improved to make the mode more sensitive to the target. This paper increasing the width of the network on the basis of a neural network. This improvement enables the network learn the key recognizable images, thus improving the accuracy of target recognition. Improvements to regional recognition network have greatly increased the running time. The detection of the number adjustment layer has also improved the accuracy rate to a certain extent. In overall, computer with the original model, the improved RCN mode, with faster speed improves the accuracy of target recognition. The end of paper. Thanks for listening.
Hello everyone, my name is Zhang Wei. I'm from Shandong Institute of Space Electronic Technology, Shandong, Yantai, China. A kind of design for CCSDS standard JF multiplier is my paper. Now let's begin. This is my context. My paper, I will give you these 5 parts. First, introduction. Second, theoretical analysis. Third, hardware structure. Fourth, analysis. Fifth, conclusion. First, we will see the introduction. In the red column code specific in CCSDS standard, the code is located in JF Goran's domain and is represented by Berlecamp. Because the basic components used in Berlecamp representation are not directly related to common Flournoy bases, Flournoy dual bases, and normal bases. The multiplication of two elements in Goran's field under the Berlecamp representation cannot be applied to more mature design method under the representation of other bases, such as Flournoy basis multiplication, dual basis multiplication, normal basis multiplication, and so on. In general, we can transform the Berlecamp basis representation to other common base representation, and the results are then converted to the Berlecamp basis after calculating. This calculation process is relatively complicated. In my paper, a method for computing two bases is proposed, which can be multiplied directly of the Berlecamp basis. The product of the two elements is still expressed by the Berlecamp basis, which greatly simplifies the calculation process and is convenient to realize in practical circuits. The second part is my theoretical analysis. The generation polynomial of JF found in CCSDS standard is shown in this formula. The Berlekamp representation of any element in GF field is shown in next formula. The basic component servers and a group of base component served UI are dual bases, and their corresponding relationship is given by paper as the table. We know that the key to implement of the polynomial dual basis multiplier is to generate polynomials in Gauss's domain, which defines the iterative relationship between polynomial basis components. In GF domain, the iterative formula is shown in the second formula. In the dual basis system, UI represented by Berlekamp, there is no iterative relationship determined by the generating polynomial, but according to the relationship between the dual basis and trace. This first formula gives us this relationship. Through calculation, the iterative relationship can be obtained the following multiplication operation. Suppose A equal B, C. The above formula is given. There is we can get the second formula. When I and J give the first formula, according to the formula 1, we can get the following results. Here, first formula produces the following iterative relationship. There is, we can see in the third formula. It can be seen that in CCSDS Berlekamp representation, there is also an iterative relationship similar to the common polynomial basis representation, which suggests that we can use a similar implementation method to polynomial basis multiplication to design multipliers. Okay, in my third part, we will get the hardware structure. First, we can see in GF addition corresponds to all operations in logic circuit, and multiplication corresponds to AND operation. The multipliers used in red solder codes usually have serial structure and parallel structure. first, we will see the serial structure. In this picture, we can see the hardware structure of the serial multipliers represented by Berlekamp is described in Figure 1. The structure adopts the form of parallel input and serial output. Each clock cycle outputs one bit of a product date. It takes 8 cycles to calculate a multiplication. The working principle of the circuit in this picture is analyzed. In my paper, we give the first clock cycle and the next second clock cycle. According to the formula, we can calculate some questions and give them results. In this way, it can be seen the circuit in this picture is essentially a plastic structure. Okay, this is my parallel architecture. In this structure, the structure of the parallel multipliers represented by Berlekamp is described in figure. The function method A is to calculate B is to B50 from B0 to B7 according to the calculation method described in question 8, and the formula function of method B is to calculate 1 bit of product according to formula 6. Taking B8 as an example, the circuit structure for calculating the bit module A is shown in left figure. In the right figure, all B method have the same circuit structure. We can see the right picture. Okay, we can see the fourth of my paper is the analysis of the sources and the time sequence. This table shows the results usage of the timing compression of the serial and parallel multipliers. In the table, NA is the number of two input AND gates, DA is the AND gates delay. NX is the number of two input OR gates. DX is the OR gates delay. ND is the number of triggers. The statistics of the hardware results in CCSDS dual-base multiplier don't include the hardware circuit needed to convert LI bases to UI bases. This is because the CCSDS need a Solomon code decoding scheme. The common Berlekamp meshing algorithm include the algorithm using multiple multipliers. These multipliers share the same multipliers and only need to one conversion. We can see the XOR gate results occupied by parallel multipliers are more than 4 times that of the serial multipliers. In FPGA, XOR gates are the scarce sources, one XOR gate from each LE, and the overall resource consumption of parallel multipliers is relatively large. The multipliers of the serial multiplier need to be saved for the next clock cycle, which increases the usage of 8 flip-flops. In FPGA, flip-flops are the rich resource and will not become a limiting factor. From the timing point of view, the parallel structure consumes more than 6 XOR gates inherent delay produced by the module than the serialized structure. Assuming that the delay of the parallel structure is approximately equal to that of the gate and XOR gate, it can be estimated that the signal path delay of the parallel structure is twice of the serialized structure. Okay, this is my final part, conclusion. The first conclusion. The design adopts a structure similar to polynomial basis multiplication. Compared with the commonly used dual basis multipliers, the multiplier does not need to transform from the Backtracking basis representation to the dual base representation before the multiplication. Second conclusion. In the conclusion process, the base transformation is performed automatically, and the calculated product is directly expressed on the Backtracking basis. The hardware structure of the base transformation is omitted, and the hardware structure is greatly simplified. Third conclusion. The serial multiplier needs 8 clock cycle processing delay, while the parallel multipliers only need 1 clock cycle processing delay, but its resource usage is large and the timing path delay is long. In the actual using process, we can reasonably choose the serial or parallel structure according to the requirements of the encoding and decoding delay clock cycle. Okay, thank you. This is my presentation. Thank you, everyone.
Hello, my name is Jiang Haohao. The title of my paper is Overview on Terahertz 3D Imaging Technology. Contents about abstract with 3D engineering technology Terahertz radar system Terahertz radar imaging algorithm. Summary and outlook. Abstract Terahertz 3-dimensional imaging system can realize the detection and imaging of near-field targets with high frame rate and high resolution and can provide more comprehensive information about the three-dimensional geometric distributions, structure of the target and imaging sign. It is suitable for the current high real-time requirements, security inspection, secure terminal guidance, military recursive, and other fields. The high-resolution three-dimensional imaging technology of radar targets in the terahertz band is of great significance to the development of radar technology and the application for radar imaging. In this paper, the research background and significance of the terahertz near-field imaging technology, radar three-dimensional imaging technology, the development status of terahertz radar system and terahertz radar imaging algorithm are reviewed, and the exciting problems of terahertz near-field imaging technology are summarized and prospected. Radar 3D imaging technology. The concept of interferometric processing technology is to extract the phase difference of the same resolution unit through a signal of observation of multiple antennas or multiple observations of a signal antenna to obtain the information of the observed solution unit in the vertical line of sight and the direction of the flight path. Image-based to achieve three-dimensional imaging of the observation area or target. The advantage of the interferometric three-dimensional imaging technology is that the number of AV elements is relatively small and the interferometric measurement accuracy is high. However, the interference processing technology assumes that only one scattering point is included in the same resolution unit. Only one elevation information can be calculated through the interference phase between antennas, so there is no resolution ability for scattering points in the same distance unit. The scientific aperture formed by the circular trajectory of the radar movement or the multiple trajectories that enable the radar to achieve three-dimensional resolution based on the two-dimensional imaging is called the scientific aperture three-dimensional imaging technology, including circular SAW and tomographic SA compared with interSA can distinguish the multiple staggering points in the same range. Atmos resolution unit which can realize true-send imagery, and the system is simple to implement. However, the synthetic aperture send imagery technology requires high trajectory accuracy of the flight platform, and the image registration is different, and the system has a long accumulation time, so the image registration is very difficult. ARISA is a two-dimensional virtual array formed by cutting trick array or multi-input, multi-output antenna combined with resolution and the high-dimensional resolution brought by band-wise signal to obtain three-dimensional imagery results work in front view or down view mode. The advantage of the array 3D imaging technology is that the imagery frame rate is relatively high, but the number of array elements required by the system is very large and the cost is high. Terahertz radar imaging system. The JPL of the United States is an important research institution in the field of terahertz imaging and has achieved many research results. The figure 1 is 675 GHz radar imaging results of the JPL laboratory in the United States. Figure 2 is conceptual diagram of 350 GHz active detection imaging system. Figure 3 is 350 GHz active detection imaging system. In 2007, the JPL the first high-resolution terahertz radar imaging system. Its working frequency is 560 GHz to 635 GHz. The imaging distance is 4 meters. The range resolution is 2 cm. In 2008, the radar type is active comprehend terahertz rate. The working frequency is 580 GHz, and the range resolution can be a millimeter level. In 2009, the radar type is active detection imaging system. The working frequency is 350 GHz, and its range resolution can be 1 cm. In 2011, the radar type is a three-dimensional scanning terahertz radar imaging system. Its working frequency is 675 GHz. The imaging distance is 25 meters. In 2015, the radar type is radar array transfer The working frequency is 340 GHz. In 2015, the reader type is a reader integrated array train service. Its array elements. Beginning in 2007, Germany has carried out a series of research on terahertz radar and ISA imaging. Figure 4 is the imaging system of RS. In 2008, FGAN rate type is COBRA 220 reader system, and its working frequency is 220 GHz, and its imaging distance is 135 meters, and its range resolution is 1.8 cm. In 2011, RS array type is a QPASS system. Its working frequency is 70 to 80 GHz. In 2013, FGAN's rate type is the MIRANDA 300 reader system. Its working frequency is 325 GHz, and its range resolution is 3.75 domestic terahertz radar system. Domestic research units include the Institute of Electronics of the Chinese Academy of Science, the Chinese Academy of Engineering Physics, the University of Electronic Science and Technology of China, and the National University of the Defense Technology. For example, in 2012, the Institute of Electronics of the Chinese Academy of Science designed and developed a three-dimensional array system with a center frequency of 0.2 THz and a sweep bandwidth of 14 GHz. The imaging resolution of the system has reached 8.8 mm, realizing the sound imaging reconstruction of the human body, model of hidden dangerous objects under the terahertz course light Gaussian beam. Figure 5 is sound imaging results of a human model with a hidden pistol. Terahertz with imaging algorithm. The first is terahertz with imaging algorithm based on time term. Terahertz with imaging algorithm based on frequency term. Figure 7 is sound imaging process based on RNA algorithm. Terahertz with imaging algorithm based on range Doppler domain. Figure 8 is RD algorithm follow. Summary and outlook. Summary. Compared with traditional readers, Terahertz readers have higher speed measurement accuracy, target recognition, and imaging capabilities, and strong anti-jam capabilities, as well as very good anti-stealth capabilities. Terahertz reader also has the ability to penetrate plasma to detect targets. However, judging from the development status of Terahertz imaging technology, there are still many problems to be solved urgently, and serious challenges are still faced. Outlook. The imaging results of the traditional BP imaging algorithm are accurate, but the algorithm has a huge amount of calculation and long imaging time. To solve this problem, we can further optimize the BP imaging algorithm to make it more suitable for Terahertz three-dimensional imaging system. To the traditional distance migration imaging algorithm has the problems of long interpolation time and inaccurate interpolation, which will affect the imaging quality. It is necessary to further study the fast and accurate frequency dimension imaging algorithm suitable for Terahertz three-dimensional imaging system. Thank you for listening.
Hi, good morning. My name is Dr. Lam, and today I'm going to do a presentation on my research work done by my students based on a search tree algorithms with the title called Evaluating the Recursive Backtracking Depth First Search Algorithms in an Unknown Search Space for Self-Learning Path Finding Robots. So as you know that most of the work here is done by my students, so if you have any feedback or any questions, do feel free to email it to me and I'll forward the questions to her for answer. So various path and route solving algorithm has been widely researched for the last 30 years. It has been applied in many different robotic systems such as bomb snuffing, path explorations, and search and rescue operations. For instance, an autonomous robot has been used to locate and assist a person trapped in the jungle or building to escape during a quake. And today, numerous math-solving algorithm has been proposed based on some information available regarding the maze, or it can either be also remotely controlled. However, in a real-world scenario, robots are usually placed in the unknown, hazardous terrains, and it is usually required the robots to be able to learn the path and exhibit a good decision making, capable of navigating the path successfully without any human assistance. And they also need to be able to adapt to dynamic environments so that it can actually change the path when it is required. So as a result of that, such path algorithms are usually used and built into robots. And it is important that such algorithms can actually find the locations quickly and energy efficiently, as most of the robots are usually energy restrictions. So as a result of that, in this paper, the main contributions of this paper is we actually propose an AI-based recursive depth first search to explore and determine the optimal path to target locations in an unknown maze. So we actually developed a novel AI-based algorithms using an uninformed depth first search to explore an unknown search space and apply the optimization algorithms known as the recursive cul-de-sac backtracking to mark and eliminate all the unwanted path for route optimizations. And we also perform a quantitative analysis on the robotic platform based on the low-powered and low-cost microcontrollers robots to actually solve the robots automatically and autonomously. Okay, so a reinforcement learning technique is actually used by the robots to learn about the new environments and update these environments. So there have been a lot of work done on this path solving algorithms, and it's commonly that use that the extra shortest path, usually known as the best to perform, both in time and hardware, is not critical compared to the flooding and wall following. So Misha and Bender actually show that the extra algorithm can effectively be used. However, if both the time and the hardware constraints are not satisfied, then they actually shown that the flood field are usually preferred compared to the wall following and the extra. And again, flood field is it's capable to do that, but however, it can be very energy efficient because you actually need to go through all the networks and then come back with the optimal path in the maze. So as a result of that, the basic and simplest wall following algorithms is the most supporting algorithms in the hardware. And Sharma actually shows that the same results where flood field algorithm can actually outperform the extra, and the wall following algorithm logic have the same performance as the flood field algorithms. In other comparisons, the lead algorithms and the flood field algorithms was actually compared against the wall following. And these algorithms is based on the extra that actually uses a breadth first search. And it works actually in two phases, i.e. the filling phase, in which the cell are actually marked and retract, and in order to derive the concept of backtracking. And the tree is actually examined from the top down, such that every node at the depth D is actually examined in the algorithms. So starting from the source vectors, the entire layers of the unvisited vertex is visited by some vertex, and then in the visited sets. And the entire visited vertices is actually added to the visited set itself. Although flood-fill is actually the most famous algorithm and most efficient energy to solve all type of maze, it is commonly set with a preset target points. And this is usually not available if you have an unknown terrain. Okay. So finally, a depth search algorithm is also used by another authors, where they actually start from the start of the graph, from the roots, and then the nodes is actually ascending from the left to the right. And the exploration continues towards the deeper ends of the tree or the graph until it reaches the dead end and need to backtrack. And this algorithm actually searches the specific vertex, and then it will navigate by branching out the corresponding vertices until it reaches the final goal. So this particular algorithm is actually can work in both ways. It can actually go from left to right and from right to left. It's also possible. So based on the depth first search algorithms, we have actually proposed to use the blind search approach in our robotic systems. So this robotic system will actually have a few input sensor, and also you have a software, and it has a motor driver to maneuver the whole robot itself. So the working principle of the robots in solving the line maze is actually provided by the system functions as follows. So it's actually have a line tracking system, okay, where the robots will actually follow the black line maze by sensing the environments using the input sensor module. And the sensor value is actually sent to the software system, which the controller will be processed, and the functions will actually instruct the robots to follow the lines as they perceive and act according to the instructions sent to the system to the motor driver. The second one is the depth first search pathfinder, where it's based on the output sensory of the module informations. The robot will actually learn to identify the route path taken using the pathfinding algorithms. The robots will actually apply the system will actually apply the depth first search algorithm to explore the maze to achieve its goals, and use its knowledge through the computational perceptions and the action condition rules to learn about the route to reach the goal itself. And finally, we applied the path optimization functions using the recursive backtracking algorithms, where the robots will actually enter to the learning phase and optimize the path, where the robots will actually go through the tables, okay, the learning table, and then try to learn where there's any backtrack, any dead end, and we try to remove the route from the routing table itself and simplify it to a much better routing itself. So in terms of the platform design, the robot is actually divided into three parts. The first part is the mobile robot navigation system, where the robot is actually highly dependent on the sensor, and that the output of the sensor is actually fed into a Arduino microcontroller, which is based on the action conditional rules. So as the input is processed, the corresponding output will be sent to the motor driver here, okay, which will actually use to navigate the robots by rotating the corresponding wheel itself. So this particular robot's navigation system will actually act as the model-based agent itself. And then the second part is actually the AI, where the knowledge-based application is incorporated with the depth first search based on the left search variant rule. So the first priority is given to the left. If there's no left junctions, then we actually move to the straights, and if there's no straights, then we'll go to the right. So we actually explore all the maze based on the left, straight, and right. And in the teaching phase, it uses the rule to navigate and traverse through all the path, including the dead ends. And when you enter the dead ends, you actually turn back or do a 180-degree turns, and then traverse the same path again. And the turns are actually stored at the junctions, intersections, and then it will be used by the robots for navigations after the path has been optimized, which is done in the second run. So in the second run, the coded set of techniques will be applied such that the optimized path is actually used to send the robot back to its original positions. So when the robots want to go back to the original positions, we will actually go through the table, eliminate all the that end, and then so that you can take the shortest path back to the source itself, okay, to the beginning part of the robots. So this is something similar to reinforced learning in the artificial intelligence. And the final part is the robot control driving system, where it is a hardware based, which is based on a 5-channel infrared sensor to detect straight lines, left and right turns, and to perform a U-turns. And in addition, an ultrasonic sensor is also used to avoid the obstacles. So if you look at the truth table here, so the truth table on this table number 2 here is actually used by the input sensor 1, 2, 3, 4, and 5. Will use to detect if it is a, so when you reach a junctions, so this is basically indicating at junctions, you actually will go to the left, and the output of the motors will rotate accordingly. And then when it is a straight lines, when you take a straight lines, you actually go straight, and this is actually indicating a left, you will turn left, that is a left turn only. And this is used actually to detect if the robot is slightly out of the path, to make sure that the robot is actually maneuver back to the original straight lines. So all this is actually based on the 5 infrared sensor. And for this one, for the second table here, actually indicate the path simplifications, where you actually remove all the dead ends. So what happened is the B here is actually indicating the robots did a U-turns. So when the robot meet up that end, you actually do a U-turns, and all the U-turns will be changed according to the optimized path. So for example, when you do a left, back, and left, so which means the left turn is actually a dead end, so the next time the robot should actually go straight. Okay, and for example, if this is left, back, and straight, which means the robot has to turn right instead this time. Don't go to the left. So this is actually the reverse path back to the original locations. So in order to evaluate our proposed algorithms, we actually built a portable robots, okay, where you actually have 2 models, left and right model here, connecting to the wheel. This is the 5 infrared sensor, which actually send the ground. And there's also, this is the left and right models, and there's a battery source, and as well as not shown here is the ultrasonic sensor to avoid obstacles. Okay. And then we actually evaluate the algorithms using a 4-line maze, 4 different maze, okay? Not 4 lines, but it's a 4 different maze. And then we actually randomly put the robots in 10 different random positions for each of the run of the maze. So we actually use 1, 2, 3, 4 different maze, and we place the robots in different locations and run the experiment for 10 times. So when we run in terms of maze 1, maze 2, and maze 3, maze A, B, C, the experiments actually shows that we achieve 100% success rate, where the robots actually have managed to find the optimal path. And only in maze 4, it actually failed to find it's not 100% achieved, which means sometimes you will not find the route to the destinations, to the target points. So this is the target point that the robots was trying to find. Okay. So as a result, in this paper, we have actually proposed an AI-based maze solving robots, and we actually have built a robot to evaluate the AI functions. And the random deployments of these robots experiments have shown that 100% success rates. Hence, this autonomous robot can be deployed in any locations that is actually accessible by the rescue teams, or that can be danger to human interventions. And the experiment also showed that by using the RBDS to calculate the optimal path, the robots can actually move from one point to another point in the most energy efficient way, and also using the shortest path. Because of our QD6, we actually remove all the redundant path and ensure that the robots always take the optimal path to go to the original locations. The only issues that we have found out is actually the Arduino robots actually does not have enough power supply using the battery. So the robots will not run. The maximum hours the robot can run is up to 30 minutes. So there's a need to do a recharging stations. So when I mean 30 minutes, it's 30 minutes continuous. So that's all for our presentations. If you have any further questions, please do not hesitate to email me, and I will try to be at the end of this, at the end of the presentations for Q&A sessions.
Hello everyone. It's my great honor to give this presentation here. My name is Deng Shuangmin, a student of Dalian University of Technology. I appreciate this opportunity to talk about our work, FTEI, a fault tolerance model of FPGA with endogenous immunity. And our presentation will follow the order as the contents: background, system design, experiment. Moreover, the last part concludes this paper and points out the future work. FPGA emerged as a very promising AI chip and algorithm hardware accelerator. However, FPGA is susceptible to complex and changeable environment, which leads to circuit configuration information faults. Therefore, enhancing the reliability of FPGA has won a lot of research interest. These researches can be classified into two categories: fault tolerance methods with fault detection capabilities, and fault tolerance methods with fault shielding capabilities. The fault tolerance method with fault detection capabilities achieve troubleshooting by adding additional fault detection resources to the system design, such as taking deep learning algorithm as a fault detection model to monitor running data. Although this method can be used to locate circuit faults, it cannot guarantee the real-time performance of circuit fault detection and increases the difficulty of circuit design and realization. Fault tolerance method with fault shielding capabilities can shield circuit faults when faults occur, which can effectively protect the system from circuit faults and maintain the normal operation of circuit system. TMR is the most representative method. Although this method can be easily to understand, it makes the circuit more complex and difficult. By comprehensive analysis, we found that to overcome these above shortcomings, the following three challenges need to be solved. The first challenge is how to improve the real-time and accuracy of fault location. The second challenge is how to ensure the normal operation of the circuit system while recovering faults. The third challenge is how to improve the efficiency of fault recovery and strict space-time constraints. To tackle all the challenges mentioned above, in this paper, we propose the FTEI, a fault-tolerant model of FPGA with endogenous immunity. It entails FPGA fault perception, fault memory, and environment adaptation to improve the reliability of the FPGA platform. Okay, during the next 7 minutes, I will present our system design. The system structure is shown in picture. Our design goals is that in those FPGA fault perception, fault memory, and environment adaptation to improve the reliability of FPGA. These circuits are divided into modules according to their functions in the design stage to facilitate detection and recovery. The target circuit module runs on FPGA, which needs to be detected and recovered when fault occurs. The detection module is exploited to supervise the real-time state of the system. Once the detection module detects circuit faults, the circuit needs to be recovered in several clocks. In order to buy time for fault recovery and ensure the normal operation of the circuit system, the comprehension module is mentioned. We pre-store truth table data of target circuits in the circuit truth table, and the comprehensive logic controller is utilized to control data transfer of the comprehension module. The fault recovery module consists of two parts: fault recovery library and evolutionary algorithm. We preset some circuit configuration chromosomes in the fault configuration library, whose faults are known. For unknown faults, we use evolutionary algorithm to recover and then store obtained configuration chromosomes into the fault configuration library. The progress is controlled by recovery logic controller. Considering the circuit state can be divided into two categories, with fault and without fault. Therefore, circuit fault detection is actually a binary classification problem. To get the fault detection module, this paper proposed FTRL optimized logistic regression and use it to establish a fault module matching library. FTRL online learning algorithm integrates the advantage of Phobos algorithm and RDA algorithm, which can better guarantee the accuracy of module parameters and the sparsity of feature items in the training progress. At the same time, after adding non-smooth regular items, FTRL can get a better sparsity value. So we utilize FTRL to optimize the parameters of the fault circuit logistic regression module. The mean iteration formula of FTRL can be expressed as equation 1. To improve the sparsity and accuracy of parameters, all2 regular term is added to the regular term of FTRL in this paper, and the method of mixed regular item is adopted to make the solution result of the fault module smoother, and the accuracy of module prediction is also increased. The feature weight iterative formula of the optimized FTRL can be expressed as equation 5. The pseudocode of circuit fault detection based on FTRL optimized logistic regression is as algorithm 1. The fault recovery module consists of two parts: fault recovery library and evolutionary algorithm. We preset some circuit configuration chromosome in the fault configuration library, whose faults are known. For unknown faults, we use evolutionary algorithm to recover, and then store obtained configuration chromosome into the fault configuration library. This paper proposed RLAGA adaptive genetic algorithm based on reinforced learning to ensure the recovery of unknown faults. In this algorithm, the crossover operator and the mutation operator of genetic algorithm are dynamically and adaptively adjusted by the reward feedback mechanism of reinforcement learning. So, the diversity of population in the iterative process can be maintained, which avoids the algorithm falling into the local optimal solution and improves the evolution efficiency of genetic algorithm. Q-learning algorithm is adopted as the learning algorithm to strengthen the learning agent. The learning mechanism of reinforcement learning for genetic algorithm mainly includes three elements: setting and division of environmental status, agents' action divisions, determination of action reward values. The pseudocode of RLAGA is as algorithm 2. Besides, we conduct experiments to demonstrate the performance of our schema. In order to fit the actual fault problem of the circuit more closely, we use the method mentioned in reference 7, taking the 2-bit multiplier as an example. The chromosome coding string is shown in picture. Then we inject errors into CGP code string to obtain fault data. As for the experimental platform, we choose Z-board, an SRAM-based FPGA. Then we utilize its software and hardware cooperation features to conduct experiments. And the hardware part, programmable logic, and the software part, processing system, interact through AXI. To demonstrate the efficiency of the FTEI optimized logistic regression. We use the fault date of the 2-bit parity checker and the 2-bit multiplier to perform online model training on traditional logistic regression, and FTEI optimized logistic regression algorithm. The experimental results shown in Table 1 and Table 2. The FTEI optimized logistic regression performs better in accuracy both online and offline tests. Due to the complexity of the circuit structure, the average time-consuming of 2-bit multiplier needs 15 clock cycles, and 8-bit parity checker is 8 clock cycles. To validate the evolutionary recovery efficiency of RLAGA, in this paper, we do experiment to compare it with standard genetic algorithm SGA and cloning algorithm PSO, adaptive genetic algorithm AGA, and self-simulation annealing adaptive genetic algorithm SAGA. In the time-consuming and evolutionary success rate, Table 2 respectively represent the evolutionary recovery results of randomly injecting different circuit faults into 8-bit parity checker and 2-bit multiplier for 100 times, and then adopt this algorithm to carry out fault recovery operation on the chip. Comparing the results of these 5 algorithms, we can see that RLAGA algorithm proposed in this paper have achieved the highest evolutionary success rate for 8-bit parity checker and least average time. Finally, we conclude our contributions and future works. Overall, our contribution is divided into 3 points. First, to realize real-time fault location, we propose to take FTEI optimized logistic regression classification algorithm as the fault detection model. Secondly, we propose presetting chromosome of known faults in fault configuration library to save recovery time, and the truth table of circuits is used to guarantee the normal operation of fault circuits. Last but not least, to overcome unknown faults, RLAGA algorithm is proposed to raise the success rate of online evolution. As part of our future work, we will further study multi-class algorithm and improve the accuracy of fault detection, study evolutionary algorithm in higher scale designed to integrate circuits and improve success rate of evolution. Thanks.
Hello everyone, my name is Xin Liang. I'm very pleased to be here to enjoy this conference. I'm from Beijing Institute of Technology. The topic of my presentation is the design of an intelligent monitoring system for human action. Then, I will talk about my paper from these 4 parts. First is some introduction about the intelligent monitoring system. In recent years, monitoring cameras have been widely used in social security, transportation, agriculture, and so on. But traditional monitoring cameras have many disadvantages, such as it can't give real-time and automatic alarm, the release on repeated manual labor, and troublesome. If there is an intelligent monitoring system that can recognize abnormal behaviors and alarm in real time and automatically, it will be of great significance to the security field. If applied to secrecy and security, it can reduce the probability of dangers. Based on this, we designed an intelligent monitoring system. Its main purpose is to monitor abnormal behaviors of humans, and its core technology is human action recognition. In general, it can be divided into 3 categories. The first one is end-to-end human action recognition. This method inputs the original image sequence information, extracts multiple features of space and time dimensions to construct the classifier, and finally outputs the action types of human. The second one is the recognition of human skeleton pose. This method generally estimated the skeleton pose of human first, then detect the coordinate of skeleton key points, and final classifies the human actions, which often used for sport action recognition. The third one is instant-sentence human interaction recognition. This method defines the problem as a structure for human and object interaction. It detects human and object respectively, and then learns the interaction to analyze human action. Using these 3 different methods, according to the different application scenes, type of actions and functions realized, the intelligent monitoring system will be divided into these 3 parts. The second is the method we use. The first part of the system is hand action recognition. We want to protect information security in special places, such as confidentiality rooms, usually indoor. Violations of obtaining information, such as taking phones, operating computers, are all by hand, so it's very important to obtain information about hand behavior. It mainly includes 2 steps: hand location, and action recognition. The location will use the SSD and open pose method. SSD network use a single deep neural network with a small convolutional kernel. First, several initial bounding boxes with different aspect ratios are generated, and then the initial bounding boxes are returned to the correct true value to find out the target position. Our open pose belongs to behavior recognition based on human skeleton pose. According to the picture, output the key points and the connection between them. Use CNN to generate confidence mapping and form them into a human skeleton. And finally, locate the hand. The action recognition part we choose SquareNet because it can reach a relative high accuracy with the low cost of computation. Hand pose estimation is mainly to judge whether people's attention to concentrated on the dangerous area, such as high voltage and riverside without fence. If a dangerous situation occurs, our system can do real-time judgment and alarm. The head action analysis algorithm consists of two parts: face target detection and head pose estimation. The traditional method uses SSD to locate the face position in the image, and then extract 2D information of key points of the face to match with 3D face model. Finally, PNP algorithm to use the 2D and 3D transformation to get the head pose. The machine learning method we use the fast network. It uses the attention mechanism for similarity calculation to obtain the hand pose. Then converts the regress task into a classification task. Divided the hand angle into several intervals, predict the discrete angle, and estimated the hand pose. This figure is the calculation processing of attention mechanism. Similarity function FQK is used to calculate the weight SI of a certain position, and the softmax function is used for normalization processing to obtain the final attention weight value. The image is weighted to improve the quality of the network. Since we use the 2D image to judge the people's 3D angle, we need to convert the image into a top view with the ground as the plane through perspective transformation according to the position of the camera. The coordinate position XY in the real world is calibrated by the camera. This picture is after perspective transformation to the XY plane. When there are many people in the scene that need to be estimated, or multiple behavior of the same person, the system uses global human-object interaction action. We use two different methods to realize this function. One is an improved method based on YOLO structure that combines target detection and action recognition simultaneously, and another an ICANN network that combines the attention mechanism with the instance-centered. As shown, the improved network based on YOLO consists of three parts. The first part is the feature extraction network, which consists of 24 convolutional layers. The second part is two branches of target detection and interactive detection with the extracted features. One output is the classification probability and the detection frame, and another output is the probability of the interaction relationship, and the positioning bounding box. The third part outputs the final result. In order to eliminate the influence of the center of human and object in the detection, the bounding box should be corrected. The ICANN network first detects human and object through the first RCNN algorithm and obtain multiple bounding boxes and probabilities. After that, the three-way branch network is used to extract features. Human and object output bounding box, probability score SH and SO. Spectral configuration outputs position relationship score SSP, and then the final action score is obtained by this formula. Attention mechanism is used here to extract features and convolve the image, get the error of attention, and improve the recognition accuracy. The third is the experiment and results in real scene. The dataset of the hand behavior recognition experiment is nearly 80,000 action frames captured in the video. This figure is the test result. The final system realized that it can recognize 7 types of behaviors, such as playing mobile phone and using keyboard, and output the 3 types of results with the highest probability to determine whether it's abnormal action and alarm. The accuracy of both SSD and OpenPose method can reach more than 95%, and the recognition speed of SSD is better than OpenPose. Hand pose estimation use 300W and 300WLP as the training dataset. The picture on the left is the result. The deep learning method is basically same as the classic method. The formula on the right is the evaluation index, which uses mean absolute error. Look at this table. The classic method has a large error in pitch and roll because not all pictures are suitable for 3D face model. The all error of the deep learning method is small. The training data set of human-object interaction detection are VCOCO and HICO-DAT. It can be seen from the figure that both methods can complete the function of recognize human action. Evaluation index is the mean absolute error AP. You can see that based on YOLO improved network recognition speed is fast, but the AP is slower than ICANN network. The ICANN network can recognize multiple actions of each person, but it takes a long time. It's determined by their different model structure. The last is conclusion. The intelligent monitoring system for human action we designed can complete 3 functions. The first uses SSD and OpenPose to locate the hand, and use SqueezeNet to recognize the hand behavior. The second uses SSD to locate the hand, and use the classic method and machine learning method to estimate the hand pose. The third one focuses on detecting the interaction between human and object. It uses first RCN network to locate, and then use the ICANN network and an improved network based on YOLO to recognize human action. But now, the system depends heavily on the object and the environment. When human and object are largely shielded, the detection effect is not good. So we plan to improve the network's balance of speed and accuracy, and to use render sensors for recognition in the future. That's all. Thank you.
My paper's title is Coding Technology of Building Space Marking Position. Firstly, let's look at the abstract. The data generated in the process of planning, construction, and management of construction and building is diverse and large in scale, and there is an urgent need for a unique, consistent, and efficient code. Based on the coding rules of Beidou grade position code, this paper proposes a construction building space identification position coding technology to code the construction building. The application of coding rules is introduced in the paper, including code generation and coding index, as well as the corresponding query algorithm, which is verified by engineering experiments. And I will explain my paper in 6 aspects, including introduction, overview, scheme, algorithm, experiment, and summary. The first part is the introduction of the paper. Let's see the current research situation at home and abroad. In building coding system, in 2006, the International Organization for Standardization formulated the ISO IDS framework. The American Building Standards Institute (CSI) and the Canadian Building Standards Institute (CSC) have promulgated the OMI classification system. In 2018, the Ministry of House and Urban Rural Development of People's Republic of China issued the Building Information Model Classification and Coding Standard GBT 51269 2011, and then there is 4 problems. The first is position representation. The special position representation of the components inside the building is based on the local reference coordinates. Next is that the existing building codes only consider simple building object information and cannot directly contain the relationship or relative positions in the building, and then that's not unique and consistent. The last is that it's not efficient. Okay, let's look at the second part. The second part is the overview of Beidou's 3D grid position coding. First of all, let's take a look at the machine dividing. Beidou's 3D grid position coding follows basic coding principles: uniqueness, nesting, compatibility, calculation, and practicality. In the two-dimensional grid division of the Earth's surface, the origin of the grid is at the intersection of the equatorial plane and the prime meridian, and the two-dimensional grid is divided into 10 levels. Okay, let's see the encoding rules. Beidou's 3D grid position code is composed of two-dimensional code and height-dimensional code intersection, a total of 32 code elements. The Beidou 3D grid position code is composed of 12-bit code elements. The structure and code element values are shown in this figure. The third part is the scheme. To locate a building, it's necessary to locate the entire building and the internal component interiors of the building inside the building in order to ensure the expandability of the internal and external divisions. The external position marking points are the starting points of the division. After determining the starting point of the internal division, the directions of the two axes of the plane are also consistent with the two axes of external global position coordinate system, which are true north and true east directions. The entire eventually falls in a certain subspace, and the third axis position is performed in the three-dimensional space. Then let's talk about the identification of the entire building. First, locate buildings on a global scale and perform unique spatial identification. To identify the building, choose a suitable identification point and use the center of the ground projection range of the building as the identification point instead of the actual area curved. After obtain the identification point, identify the point in the global position frame. In order to avoid that the identification points of the two buildings fall on the same grid and lose their uniqueness, a grid of appropriate size is selected so that the grid length is not greater than the distance between the two. Then we should explain division and coding of building floor height dimensions. Coding considering the division of the height dimension of the building. The starting plane of the division is specified on the ground in the building. The upward direction is positive direction of the height axis and vice versa. The building code is extended to the floor height as C0MNF. Next is floor plan division and subspace location code. In each floor of a building, many components need to be further divided into space to obtain a more refined space to determine the precise location of the components. After the identification points of each subspace are obtained, their true north and true east offsets in the floor plan coordinate system are M apostrophe N apostrophe respectively. The location code for constructing the building code to extend to the subspace level is C0MNF M apostrophe N apostrophe. Okay, in further, let's see division and coding in subspace. Each subspace in the floor plan coordinate system has its own independent coordinate system constructed inside, and they are related by the floor plan coordinate system and the offset of the respective subspace identification point from the floor identification point is used as the identification code. Each subspace in the floor plan coordinate system has its own independent coordinate system constructed inside, and they are related by the floor plan coordinate system and the offset of the respective subspace identification point from the floor identification point is used as the identification code. In the subspace, the component is encoded in three-dimensional space to obtain the offset PQI in the three axis directions. The location code of the construction building code extended into the subspace is C0MNF apostrophe N apostrophe PQR. Okay, let's take a look at the first part. The first part is the algorithm. First, let's see code generation algorithm in building design stage. Step 1 is that determine the local coordinate system of the component in the BIM, then determine the target coordinate system for transformation according to the date in the BIM file. Next, using the principle of coordinate transformation, the coordinate S0 of the component's center point. A local coordinate system is transformed into the target coordinate system. Next, first calculate the offset of the three axes of O in the coordinate system O, and then calculate the cosine of the including angle between the x apostrophe axis and the x axis, y axis, and z axis respectively is cosine alpha 1, cosine beta 1, cosine gamma 1. The cosine of the angle between z apostrophe and x y z axis, cosine alpha 2, cosine beta 2, cosine gamma 2. Finally, the coordinates of the identification point of the entire in the building coordinate system can be obtained by the equation T times S apostrophe equals S. T is shown below this PPT. Okay. Then let's talk about multi-source building date integration algorithm based on coding model. Many themes in the building industry are spatial location to associate multi-source data, such as file association management, automatic inspection, and intelligent construction. Analyze the needs and feasibility of location identification codes in the integration of multi-source data, then design a large table of split index coded as raw key, and on this basis realize the efficient integration of multi-source data in the construction industry. Next, I will explain data retrieval algorithm based on coding model. Firstly, let's see point query. The specific requirements in this research scenario are that when a file occurs, the file hydrant near the location of the firefighter. The nearby range here is limited to the same floor as shown in the figure below. You want to query the objects near the location of the asterisk, which is the range of dotted circle. This range includes 3 subspace BCE. Then we talk about range query. Range query refers to query all objects within the framed range. The specific requirements in this research scenario are query all beams in a room as shown in subspace C in the figure, or delete it and arbitrarily closed graphic to query all specific components in titles contained in it, as shown in the figure below, that spans 3 subspace ABC irregular shades of blue. Finally, its distance query with constraints. The query in the building must consider the structural characteristics of the building itself, such as the distance between the components A and B in the 2 zone due to the barrier of the door, not a straight line distance, and there are multiple possible passes. In the fifth part, we will talk about experiments based on the self-designed building data visualization and management system. This section carries out typical application experiments such as code generation experiments, building multi-source data association and query from building establishment and application to verify the correctness, efficiency, and feasibility of the coding model. Choose B as web application framework verification based on WebGL and HTML5 language. The framework name and function are shown in this figure. The component data table is a key in the JSON dictionary based on the structure of the building code, while the value is composed of multiple attributes realizing faster search based on key value pairs. The experimental results, as shown in the figure, enter the subspace and choose an entire to pop up the properties of the component itself and the multi-source properties of the associated subspace. Point query. Take the point query in the subspace as an example. The user selects the query point. The default query radius is 10 meters, and the query result is shown in the first figure. Range query. The user's arbitrarity specifies a certain range to get all specific integers in it, which may be a certain floor or an irregular program that breaks through the existing boundary of the building, as shown in the second figure. As shown in the figure 1. As shown in the figure 1, in the query scenario, the query can only be performed based on the outsourced patch of the subspace. If a smaller grid with a larger neighbor is used in aggregation, irregular polygon, like the subspace are fitted, it requires constant iterative calculations, and the amount of calculation is large and the efficiency is not high. Figure 2 shows a schematic diagram of the effect of global rigid grid division. The last part is summary. The final part, construction information management, plays a huge role in the implementation, construction projects, and the macro management of the construction industry is not only the function of the project management but also the foundation of project management. The fair play of IT technology in the construction field requires standardization and unification of construction information, which is also the basic link of construction industry informatization.